Alright, so back again with my cracking on Linux tutorial number 5. It'll be another quick one. I'm going to show you this time how to crack a binary or circumvent the protection of a binary without even looking at the code, without opening up in GDB or anything at all. So just a quick review here. The binary is login. It's protected by a password. Put the wrong password, it's access denied. If you put the right password in, you're authorized. So we want to find a way to circumvent that because we're obviously not going to know the password. So how can we get that to let us have access without knowing the password? So what we're going to do, I'm going to show you a man page for the linker here. LD is the actual, the linker. So what this does is it actually will link shared object files, like the standard C library, into binaries. Now, one thing that I want to show you is there's different environment variables that you can use with LD that actually reads, and a very important one here, one that we can use to our advantage, is called LD preload. Now this is a method I used to use, back when I was younger as a kid. LD preload was all the rage. What we did was we used that to set up rootkits on systems. We took advantage of that, and I'll explain how that works. So basically what it does is you can set up a list of additional user-specified ELF shared object files. So you can write your own shared object file, and they can be used to selectively override functions in other shared objects. So what that means essentially is we can write our own shared object which overrides a function in libc. So knowing that, and knowing a little bit of C, knowing that it asks for a password, knowing that it somehow is going to compare those passwords, taking a guess that maybe it's going to use string compare. It's a good guess. It could use it may not be string compare. It could be other stuff, but it's a good starting point. You see here, string compare function compares to two strings, which means integer less than, equal to, or greater than 0, depending on how the strings compare. So if it returns a 0, it means your strings are equal, and you'd have access, again, if you use a string compare. So we know that if we can force string compare to always return 0 somehow, we'll get access to the binary. Now, knowing the way LD preload works, we know that we can write our own shared object file, load that first, override string compare, have it return 0, and give us access. So let's see how that's done. I'll write my own string compare here. I call it mystringcompare.c. All we need is function prototype for string compare. So, all I'm doing is making this function return 0. So, this is kind of a dirty way to do it. There's a better way where you actually call the old string compare if if it's not the one you want to actually intercept. But I just want to show you guys an example here. So what we're going to do is just intercept string compare, always return 0. So essentially it's like the strings are always equal. So let's compile it. Now, these are the flags you have to pass to GCC to actually compile a shared library. So mine is shared. fpic is position independent code. You can read about it, but don't worry about the semantics of it. Just know that these are the flags you pass to actually compile some code into a shared library. Alright, so it's compiled. So now what I'll do is I'm going to set that environment variable, the LD preload. So let's go like this. Let me just compile it first. First compile the login. Show you again that it's, let's just go with this one. Doesn't work. Now, if we do something like, so what I'm doing there is I'm setting an environment variable LD preload to equal the current working directory mystringcompare.so. That's the object file that we just compiled. Now what's going to happen is the linker will first search for LD preload, for any kind of libraries in LD preload. It'll find this, and inside that shared object code is a function string compare, which will overwrite the libc string compare. So it should return 0. It should give us access. So now if we run login, there we go. Like that, we're authorized. Anything will be authorized now because inside the program it actually is using string compare function, and now we basically overridden that function and made it always return 0. Without knowing the source code, without debugging the source code, just a random guess that they're probably using string compare, and easily fixed. Now this again is very basic. A lot of people protecting their binaries, they'll probably be aware of this method. They'll probably try to avoid it. They may not use string compare. There's ways they can protect the binary so that it can't be hijacked with LD preload. But it's another kind of tool that you can use. And it's kind of a cool one too. I mean, it's not limited to string compare. I mean, it could be some kind of other protection, some kind of reading a file or something. You can intercept file open calls, file read calls, what have you. So that's it for this tutorial. Another short one. I think what I'm going to do is move into more kind of hacking oriented tutorials next.